Let us deal with a program to implement the concepts of recursion. We have stated that when a function gives a call to itself, the process is known as recursion. Let's try and implement this task to find factorial of a given integer number. Now, we have been saying that a factorial program had been done using a for loop, then it was done using function. We are trying the same example for the third time. This time we are using the recursion concept. How exactly we carry out this particular recursion operation? Assume that you are a function and I am a main function. Let's have a game between us. So for a while, just presume that you are a function and I am a main task. I'll be asking the number from the user and I'll be giving it to you. So I hope the concepts are now much more going to be interesting, because when you interact, when you actually virtually presume, then the things will be much more easier. So presume that you are a function and there are some people around you who are identical to you, right? So assume that there are some around 4 people who are sitting next to you, sitting aside by you, and all are of same nature. Let's keep a name for you. I'll call you now called as fact. I'll say that you are a function for me and your name is fact. Now I'll put some limitations for you. Assume that whenever I give a number to you, you have the knowledge of factorial of 0 and you don't have any knowledge of factorial of any other number. Is that clear? So presume that you are a function fact and the limitations with you are you can give me factorial of 0, right? So if I ask you factorial of 1, you should not spell the answer as 1, because you don't have any knowledge of any number apart from factorial of 0. Clear? Okay. So you are factorial and your limitation is that you have the knowledge of factorial of 0. I'll put one more limitations with you. Assume that you can multiply 2 numbers. You can't add, you can't subtract, you can't divide, but you have knowledge of multiplication of 2 numbers. So let's recollect this. Your name is fact and your limitations are you can multiply 2 numbers and you know factorial of 0. That's it, right? Okay, let's start with this particular task. So I'll give you a number for you now. So I'll ask you factorial of 4. I'll ask you to get the factorial of 4. Do you know what is factorial of 4? You have to say I don't know, because I have given you a limitation that you know only factorial of 0. But you have one more limitation, that you can multiply 2 numbers. So when I give a number to you, since you don't, you'll first check what is the number which I said. I have said 4. I'm not knowing, I don't know what is factorial of 4. For that, what you'll do is, you'll say, I don't know factorial of 4, but there is someone who is next to me, who is having the same name called as fact. And that someone is also knowing the factorial of 0. That someone is also having knowledge of multiplying 2 numbers. That's it. You don't have any other qualification apart from these 2 tasks. So what I'll do is, I'll say that I can get you factorial of 4 if that someone who is next to me can get me 3 factorial, because I know that I can multiply 2 numbers. So what I'll do is, I'll say I'll keep number with me and I'll ask someone to do the task of finding factorial of 3. That someone is again identical to you. Who is sitting next to you is someone identical. So what he does, he says, is this number 0? No. Then he says, I don't know what is factorial of 3, but I can get you factorial of 3 if someone gets me 2 factorial. So the number rolls to the next person. So now here, I'm main, I have given you a number called as 4. You have passed that particular number to the next person as 3. Then that next person passed the number as 2. So he says, is this number 0? No. If not, I'll say, I'll keep the number with me and I'll ask someone to find a factorial of 1. Now the 4th person receives a number called as 1. The 4th person is also not aware of factorial. So what he does is, he says, I can get you factorial of 1 if provided that he gives me factorial of 0. Now here, one final lucky person will get the factorial as 0. Now when the number is received by that particular final person who is exactly identical to you, what he does is, he says, yes, I know factorial of 0. None of you were actually knowledge, but I am knowledgeable person, I have factorial of 0. So as soon as the person receives 0 factorial, he says, yes, factorial of 0 is 1. Now the return process starts. The factorial of 0 is 1. When 0 is given back, so when 0 factorial receives 1, obviously the person who has requested 0 factorial, the return will be only for them. This 0 factorial will never respond to 4 factorial, it will always respond to 0 factorial. So 0 factorial responds to 0 factorial, that is answer as 1. So what this person does, now this person multiplies these two results. 1 into 1 is 1. So this gives the value as 1. Now this person who was waiting for 1 factorial received the answer as 1. He now multiplies these two values. 2 into 1 is 2. He again gives you the value back. So 2 into 1 is 2. So now in this process, 2 factorial received the answer as 2. Hence it goes and says that 2 factorial is 2. Take this and multiply. 3 into 2 is 6 factorial. So now it returns the value as 6. The one which are marked with this color, they are all the return values which are associated with these return values, which are associated with these numbers which have requested for the return values. So finally 6 is multiplied by 4 and you lucky person will get me the answer as 24. But the task, was it done by you? No, the task was shared by different people and I had only some limitations. I said that when a number is received by me, what I did was, I checked, is it the one which I know? Is it the one which I know? Yes, if you say, then you will say answer is 1. Because you know factorial of only 0, the answer is 1. If not, you said, wait, I'll get you the factorial if someone can get me factorial of the number minus 1. So that someone is again having the same name as of you. If I had given you a name fact, the next person who is sitting next to you, the next person who is sitting next to you, they are all fact itself. They are all having the same limitation. So I have said the recursion process in this ladder diagram. But as such, in these cases, none of these functions, they use looping structures. Let's see how we implement this in programming languages. Let's see this particular program which will help us to understand the recursion concept. So here, as usual, the simple main task, I'll say long int n is the number whose factorial need to be found, long int f. I'll clear the screen, I'll ask the user to enter the number scanf %d, ampersand of n. Now once the number is read, here I'm going to give a call to a function called as fact. What need to be passed? N. I'll say fact of n. And this return will come back into variable f. And whatever the result which is going to come back, that will be stored in this particular factorial. So it says factorial equals to %ld, f. So now when fact is called, it goes to the other side and gives a call to fact function. So now I'm not supposed to use loop, I'm supposed to implement the one which I said in the ladder diagram. When a number is received, what do? You have to check, is this the number whose factorial I'm aware of. So how do you say that? I'll say, in this case, the contents will be written as, I'll check if, what you said, n equals to 0. Is this number 0? If you say yes, then you will say the answer is 1. I'll say return 1. Or what I'll do is, I'll declare a variable as long int with f equals to 1. And here I can say long int f and return f. So if f equals to 1, you'll say return f. If not, then it will go into the else part. So if n is 0, you will say 1 as the answer. If n is not 0, then what you did? You said that I'll keep the number with me. Where the number is stored? The number is stored into n, number with me. And then I'll ask someone who is having the same name. What is that someone? That someone is fact. So I'll say fact. So here we have to keep the number with us, that is n, and then multiply this particular n asterisk. So here I'll say fact. The same function has to be called. The same, you called the person next to you who is identical to you, who is having the same name as fact. So fact, what you passed? I'll say n minus 1. N asterisk fact of n minus 1. This result let us store into f. And what are the value which comes into f? I'll say return f. And here I'll end up this particular function. So here, have I used any looping structure? Neither a for nor a while nor a do while loop appears, but here I had used the function to call itself. So this is the place where I exhibit recursion. So f equals to n asterisk fact of n minus 1. It goes to this particular place. It goes to this particular place, again gives a call and start doing this particular operation. Now let's explain this particular ladder diagram one more time. How exactly it works internally. Let's see this. So if I say that I'm supposed to give a call to a function, let's take n as say 3. So you said fact. In this main, I'll say that I have read a number as 3 and you're going to give a call to a function fact 3, right? So fact 3 gives a call to this. Now let me have functions at this place. So function will be called with fact of 3. So n is 3 now. So you'll check if 3 equals to 0, not no in the sense you'll go into else you'll say f equals to n, keep the number with you, 3 asterisk fact of 2. So in the mid of this it will give a call. So it means that for a temporary period this function gets suspended. It will not be closed because it has not executed return nor it has executed the last curly bracket. Hence the function remains open. So it gives a call to fact of 2. So it says fact of 2. So if 2 equal to 0, no in the sense again going to else part, it says f equals to 2 asterisk fact of 1. So it is yet to multiply, it will go in the mid of this and then says fact of 1. So you'll say if 1 equal to 0, no in the sense again going to the else part. In this else part you'll say f equals to 1 asterisk fact of 0. Now here, so now finally a function gets opened up with fact value as fact of 0. So main has given a call to fact 3, fact 3 has given a call to fact 2, fact 2 has given a call to fact 1, fact 1 has given a call to fact 0. So there are people who are lined up to get completed. All these functions are kept open one by one. So finally I'll say if 0 equals to 0, then this condition becomes true. It means that it is now return 1. Now for the first time the unfolding process goes. When I say return 1, this return is for the place where fact of 0 is called. So the return value is 1 in this case. So this goes to this place. The value of 1 is multiplied with 1 and that will be stored into f, and then it says return f again. So it means that for the first time a function gets closed. So this function gets closed. Return f in this case is again 1. So that goes to this particular place. When return gets executed, even this function also gets closed. When this function gets closed, again it says multiply this return value with a 2 and store that into f. It will say return f. So when I say return f, this return f again goes to this particular place with a return value as what? 2. So the first function returns 1, gets closed. This function multiplies and then returns 1, gets closed. This function returns 1, gets closed. After that this multiplies, so 2 into 1, return 2, and again this function gets closed. So again multiply this. 3 into 2 is 6. So when I say 6, it says now go ahead and execute the next instruction, return f. So return f in the sense 2 is multiplied by 3, 6. This 6 goes to this particular place, that is main. And then this function gets closed. After that the main program will display the result. So we have seen the same task in this particular program. So here a copy is kept on opening again and again. So let me illustrate this particular program one more time. So now with that diagram you can compare this. I have f equals fact of n, this is my main, goes to this place, n equals 0, no, then go into else. If true, f is 1, return the value as 1. If not, then do this particular operation and give a call to this. So the function is now going to return a long integer value. Let's put this prototype long int and then fact, and here I'll say int and a semicolon. So function prototype, a function call, and this is a function definition in which a function is called again. So this example, the ladder diagram and the diagram which I illustrated, are sufficient to understand the concepts of recursion. So at any point of the time, if you feel that the things are much more jumbled, take a pause, look at the entire code, recollect the entire code, and then do this particular analysis. That will be much more easy for you to understand. And visualize that you are a function, the people who are sitting next to you are again a set of functions itself. Thank you.